I decided to challenge myself with an audio programming project of recreating some complex blueprints in C++. This is a useful skill as it is common in the industry to encounter situations where the audio designer has an idea for an intricate system to elevate the quality of sound design or implementation in the game they're working on. And as audio programmers, we use our knowledge of C++, programming, and the Unreal Engine framework, for example, to create these systems in the language, reducing memory overhead, streamlining the process and logic, and providing that level of abstraction that finds the balance between making sound designers' lives easier while giving them enough tools, options, and features that they have plenty of room to come up with great solutions for their sound design. A golden piece of advice from audio programmer Guy Somberg is, sound designers are our clients, and we need to do the best job we can to fulfill the requirements of our clients so that they can succeed in the development process and create some great audio solutions for our games. For this project, I decided to recreate the Vectorator custom actors, as they are called, from the Spatial Audio Utilities add-on by Richard Stevens and Dave Raybould. I first began the recreation by looking at the blueprints in detail and taking notes to understand exactly how these systems work. The Vectorator itself is a simple concept where you spawn a particle with an audio component and it moves around in 3D space according to the user's parameters. This allows us to do things like what you saw in the demo, taking the whoosh of an explosion and spatializing it around the player from the point of origin, or having debris sounds happen around these areas, or a jet that flies over the player's head. This allows for intricate and creative applications of spatial audio that elevates the immersive quality of our games. The way that this system needs to be put together is somewhat complex. We have our original Vectorator spawner where we put in our parameters like our relative location, the angle of trajectory, how the particle moves in 3D space, the pitch of the sound and the volume of the sound, as well as which sounds we're playing and when. The Vectorator then reads these parameters and uses them to spawn the particles and feeds the parameters in so that the particle behaves in the way that we've set up. You can set the angle of travel to angled sweep, where you feed in a certain trajectory and the actor moves along that trajectory in a straight line until the sound playback is over. A sweep through actor, where the particle follows another actor, usually the player, given a particular angle, until a designated amount of time passes where we want our actor to be directly over the player's head for a flyover effect, such as at the peak of a jet pass-by sound, for example, among some other settings, such as a circular sweep. First, I created the Vectorator actor in C++ that controls our spawning. I began with a header file, as usual, by initializing all of the parameters we will be using and decorating them with Unreal C++ uProperty and uFunction macros, along with the correct modifiers that make these parameters visible within the editor and able to be interacted with in blueprints. These macros are an important part of C++ programming in the engine, as they are what allows the user to interact with the parameters we've set up when using the editor. This makes it much easier to interact with our system in the editor and streamlines the process of implementation hugely. Next, I went over to the CPP file, where the actual behavior and logic of how we handle the spawning of our actors and passing on our input parameters is determined. Here, a lot of conditional logic is used to read the different settings we enter for our spawner, and this was also an opportunity to add an extra feature of adding an optional visual mesh, such as a sphere or an arrow, to be used for debugging purposes. With the scaffolding set up for how our spawner works, it was then time to create the actual vectorators themselves. For the angled sweep, the process was fairly simple, where, as usual, we have our input parameters set up in the header file for a spawner to read our parameters and to feed them in to determine behavior for our actors. And in the CPP file, we program our actor to move along the trajectory it spawns in, as well as establishing the audio component and audio playback, tying up the parameters we've set up with the actual logic that controls how our Vectorator moves around in 3D space. For the sweep through, the process was a bit more complicated. I wanted to make it so that the angle we feed in is the one at which the Vectorator moves towards the player. This meant that we had to take the angle we want and the player location, and from these figure out where our Vectorator will actually spawn in 3D space. This required some tricky trigonometry to actually work out, but in the end, I was able to put together all the maths using the fmath functions that come with the Unreal C++ library. The last step was ensuring our code was memory safe by using conditional logic to ensure we aren't reading any empty parameters to our spawner that might cause bad access errors from our code looking at parts of memory that are not actually being used by the engine. The end result was a functioning and efficient recreation of the original blueprint system in C++ that works as intended with a lower memory overhead and ease of use to allow rapid implementation for members of our imaginary audio team.